Chapter 5, Lesson 5 is solving linear inequalities. So let's define a linear inequality. A linear inequality is similar to a linear equation but you replace the equal sign with an inequality symbol. So the equations are going to look exactly the same, except for instead of having an equal sign, we're going to have a less than or greater than, or a less than or equal to or greater than or equal to. That's the only difference. The solution of a linear inequality is any ordered pair that makes the inequality true. That's also very similar to the solutions of linear equations. They were an x and a y, so they were ordered pairs. You just have to be careful now that when you find your solution that the less than is true or the greater than is true, since they are no longer equal. Okay, let's try example 1. So example 1 asks us to tell whether the ordered pair is a solution of the inequality. So just like before when we had to figure out if it was the solution of an equation, we're just going to plug in x and y. Also remember that your ordered pairs are x, comma, y every time. So if we plug these in, we have 5 is less than 4 plus 1. So we keep the 5 is less than 4 plus 1 is 5. Is that true? Is 5 less than 5? Well, no. 5 is not less than 5. So the answer is no. That is not a solution to that inequality. Let's go over and look at B. So B is 1, comma 1. So our x is 1 and our y is 1. So plug them in. So y, we have 1, is greater than x, which is 1 minus 7. So we have 1 is greater than negative 6. Is that true? Well, yes, it is true. 1 is greater than negative 6, so yes, that is a solution to this ordered pair. Go ahead and pause the video and try letters C and D. All right, for letter C, you should have found no. If you plug in negative 2 for x and 4 for y, you have 2 times negative 2 plus 1, which is negative 4, plus 1, which gives you negative 3. So then you end up with 4 is less than negative 3, which is not true. So the answer to that one is no. That is not a solution to that system, or to that inequality. And then the answer to D is yes. If you plug in 3 for x and 1 for y, you end up with 1 is greater than 3 minus 4, so 1 is greater than negative 1, which yes, that is true. So that is a solution to that inequality. The next thing we're going to talk about are graphing linear inequalities. So when you graph a linear inequality, you do the exact same thing you would as if you were graphing a linear equation. So step 1, solve the inequality for y. You have to get y by itself. You want to get it into y equals mx plus b form so that you can graph it, just like you would if it were an equation. Step 2, graph that line that you found. When you are graphing that line though, if you have a less than or equal to or greater than or equal to, you will put a solid line. If you have a less than or a greater than, you will have a dotted line. That is the only difference when you're graphing inequalities, when you are putting that line on the graph. If you've got that equal to, then it's solid because you're including the points that the line hits. If you do not have that equal to, like for these ones, then that becomes dotted because you're not including the points that are on the line because it's only greater than that line or less than that line. Then you need to shade. Your graph will be shaded in part of it because an inequality includes everything greater than that line, so it includes a whole bunch of space. So you will shade the graph if you have y is greater than or y is greater than or equal to. You shade above the line because it's greater than that, so you shade above it. If you have y is less than or y is less than or equal to, you shade below the line because your inequality is everything below that line, your solutions. Okay, so now let's go ahead and actually try to graph some of these equations. Let's go down to example 2. All right, example 2 tells us to graph the solutions of the linear inequality. So step 1, in our steps from before, we said that step 1 is to solve the inequality for y. Well, this one happens to be solved for y, so we're good to go. Now we graph this just like we would before. So -3 is our y-intercept, and 2 is our slope. So on the graph, I'm going to go down to -3 and put a dot. And then I'm going to go up 2 over 1 for our slope. Up 2 over 1. I'm going to go a few times so that I can draw a straighter line. If you can go up 2 right 1, you can also go down 2 left 1. You can always go the opposite. Okay, so we have our dots. So we know where our line needs to go. Now we need to decide if the line that we draw is going to be solid or if that line is going to be dotted. So if we look up here, we have this equal to underneath our inequality symbol. Therefore, we are going to have a solid line. So we will just draw a line on here that is solid all the way up through our dots. Remember, it's a line, so we need our arrows. Try to get as close to your dots as you can. Okay, so that was step 2. Step 3 is to shade. If it is y is greater than, we go above, less than, we go below. So if we look up here, our equation says that y is less than or equal to that equation. So if it is less than, that means we shade below that line, which puts all of our shading down here. When you are graphing inequalities, make your line go your whole grid. Make it cover the whole space so when you shade, it looks better. Because you need to shade that whole area, not just part of it. All right, now let's go over to B. All right, B is not as friendly because we don't have y by itself. So our first step will be to get y by itself. So we need to solve this equation for y. So we're going to subtract 5x from both sides. So we get 2y is greater than -5x minus 8. Now we need to divide by 2. So y is greater than -5 over 2x minus 4. Remember that if you multiply or divide by a negative number, that flips your inequality sign. That still applies here. All of those rules still apply when you are working with your equation. Okay, so now we have our final equation, and we need to graph it. So our y-intercept is -4, so we come down to -4 and put a dot. Our slope is -5 over 2, so we go down 5 and right 2. So we get a dot here. Then we can also go up 5 and left 2 to get another dot over here, just so it's easier to draw our line. Now we need to look and see what kind of inequality we have. We have just a greater than. Since there is no equal to, this gives us a dotted line. So that means instead of drawing a solid line, you're going to draw dashes. Still have the arrows because this is a line, it just happens to be dotted. Now we need to decide where we're going to shade. Well, since y is greater than the equation, we need to shade above the line. So to shade above the line, we will shade everything up here. And then that problem is finished. So that means everything in that red area could be a solution to that equation, all of those points. Go ahead and pause the video and try C and D. When you have finished them, come back and check and see how you did. Okay, when you do C, you have to get y by itself. So we need to subtract a few things. So I'll start off with subtracting the 4x from both sides. So I have a negative y plus 2 is less than or equal to negative 4x. 0 minus 4x is just negative 4x. Then let's subtract the 2. So negative y is less than or equal to negative 4x minus 2. Then we still have to get rid of that negative, so we must divide by negative 1 everywhere. So we have y. Since we divided by a negative, we need to flip our sign. So that goes this way. Then negative 4 divided by negative 1 is a positive 4. And negative 2 and negative 1 gives us a positive 2. So we end up with this as our equation that needs to be graphed, or inequality, I'm sorry, not equation. So we go to positive 2 and put a dot. Then we go up 4 over 1. Up 4 over 1. Look at your sign. We've got the equal to underneath of it, so that means we have a solid line. So we can just draw a line like normal. Put our arrows. And then we need to shade. This says that y is greater than our equation, so we need to shade on top of it. So that means all of our shading will end up here. Okay, moving over to D. D also needs to be solved for the variable, for y. So we'll subtract 4x from both sides. We get negative 3y is greater than negative 4x plus 12. Then we need to divide by this negative 3. Since we divided by a negative 3, we have to flip our sign. Don't forget to flip your sign. So negative 4 over negative 3 is just a positive 4 over 3x. And a positive 12 over a negative 3 gives us a negative 4. We now have our equation to graph. So we put a dot at negative 4, our y-intercept. Then we go up 4, right 3, we get our next dot. I'm going to do it again. So I have more dots to follow. Then we need to look at our inequality. We have a less than sign, no equal to, so that means we need to be dotted. So we'll put the little dots in here. The arrow on that end, and then I'm going to extend it this way. Remember to cover your whole grid. And since y is less than, you should have shaded below. Then everything inside of that shaded area would be included in the answers for that problem. We are going to skip the word problems for now, so you can just go straight to example 4. We'll do the word problems when I come back to class, so we can do them together. So let's go ahead and try example 4. Write an inequality from a graph. So basically what you need to do is write the equation for the line, just like we've done before. So you need to find the slope in the y-intercept, so you can write an equation in y equals mx plus b form. except we won't have an equals this time. We're going